Okay, so some of you yesterday reached out asking for help with question number 69. So I made a quick video for you guys to try and show you how to get this one right. So let's just start with the question quick, and I gotta move fast because I can't let this video get too long or it won't upload. It says two-sided test. Suppose you want to perform a test of H0 that mu is equal to 64 versus an alternate hypothesis that mu does not equal 64 at a 5% significance level. A random sample of size 25 from the population of interest yields an X bar of 62.8 and a sample standard deviation of 5.36. Assume that the conditions for carrying out the test are met. So A says explain why the sample results give some evidence for the alternate hypothesis. Well, let's look at the alternate hypothesis. The alternate hypothesis is that the population mean is not 64. Let's look at the sample results. The sample results have a mean X bar of 62.8. 62.8 is not 64. So this is some evidence that the alternate hypothesis is true. This is some evidence that the true mean for whatever variable they're measuring here is not equal to 64. Is it strong enough evidence to reject the null hypothesis that the population mean is equal to 64? Well, that's what we're going to be doing in the second part. Calculate the standardized test statistic and the p-value, right? So remember, first of all, this is a two-sided test, not a one-sided test. So with a two-sided test, I need to take this 5% level of significance, and I can't just stick it all in the upper tail or all in the lower tail. I'm doing a two-tail test, so I need to split it between the upper tail and the lower tail. So half of 5%, that's going to be 0.025 or 2.5% in the upper tail and 2.5% in the lower tail. Any test statistic that falls in the upper 2.5% of the sampling distribution or the lower 2.5% of the sampling distribution is going to result in us rejecting the null. Okay? So first of all, let's find the critical values, the cutoff points, so that the area in the left tail is 0.025 and the area in the upper tail is also 0.025. So for this, you can use the inverse t function. Remember, we're using t distributions because we're doing tests about means. If I do inverse t, and remember the calculator only accepts the area all the way to the left. So if I have 95% of the area in the middle and 2.5 in this tail, in order to get this critical value, I need to tell the calculator the entire area to the left, and that's 0.975, the middle 95% plus this 2.5. This degrees of freedom 24. Remember, degrees of freedom are always equal to n minus 1. So our our sample size n was 25 minus 1 is 24, and you'll notice that gives you a critical value of positive 2.064. So any standardized test statistic that we get that's above 2.064 is going to result in us rejecting the null. On the low side, okay, the area to the left of this cutoff point is only 0.025. Again, the same degrees of freedom, and you'll notice it gives you the same critical value except the negative version. Remember, this distribution is symmetrical, right? So I got positive 2.064 on the right. I got negative 2.064 on the left, right? Now what our goal is to see just how far away these sample results fall from what is being claimed about the population, okay? So in order to calculate that test statistic, I have to get, our sample results minus what is being claimed divided by the standard error of the sampling distribution. Now, the standard error of the sampling distribution for means is always equal to the standard deviation of the sample divided by the square root of the sample size. All right? So I went ahead and did these calculations already. The denominator comes out to 1.072. The numerator comes out to 62.8 minus 64. If you take the result of this subtraction here and divide it by the denominator, you get a standardized test statistic of negative 1.12. So if I'm looking at my distribution, right, negative 1.12 is here, negative 2.064 is here. This standardized test statistic did not fall in this region that would have me reject the null, okay? It happens frequently enough, purely by chance, given that the actual mean is 64, that I do not have strong enough evidence to say the mean is not equal to 64. I have some evidence because my sample result is 62.8, but it's not strong enough. It's just not far enough away for me to make that conclusion, right? So there's my standardized test statistic, and some people reached out asking how to get the p-value, right? So the p-value is simply the probability of getting a test statistic this low or lower. If we had a test statistic that ended up on the high side, it would be the probability of getting a test statistic this high or higher, right? So if I use TCDF, not normal CDF, because again, we're doing means, so we're using a t-distribution, the lower end of this range, I'm flipping back and forth too much. The lower end of this range is negative 1e99, you guys know that. The upper end is that critical value that we calculated, the standardized test statistic that we calculated, that's negative 1.12. And again, the degrees of freedom are 24. And here I have on my computer version of my TI 84, right? I have TCDF, negative 1e99, negative 1.12. Make sure on your computer you don't accidentally put a minus sign in here or it won't work. It has to be a negative sign. And 24 degrees of freedom. Here are my inverse t calculations from before, right? And I see that my p-value is 0.1368. So I rounded that up to 0.14, okay? So if I'm looking on the back here, right, I made a new distribution. The area to the left of this critical value on a t-distribution is about 14% of the area under the curve. That does not fall in this 2.5%, the lowest 2.5%, and it does not fall in the highest 2.5%. So again, getting a sample result of 62.8 or worse will happen purely by chance about 14% of the time, because that does not fall in the lowest 2.5% of test statistics or the highest 2.5% of test statistics. We will fail to reject the null. I hope this helped you guys. I'm going to post a picture of this along with this video, and I hope you guys all go back and review it. Thanks.